So let's go ahead and look at these questions on this test review. First, several say differentiate each function with respect to x. Problems may contain constants a, b, and c. So if we see an a, b, or c, that's just representing a constant. So let's work through these. At the top, you do see that you need to know your different derivative or differential rules. And we'll be seeing, I think, each of those on here. So here we go. The first three have to do with the power rule. So the first one, we can write dy dx. And the 3b comes out front to be multiplied by the -5. So this is going to be -15b. And then we have to subtract 1 from that exponent. So x to the 3b minus 1, and they're not like terms, so we just leave our answer like that. Number two, what we do is we like to rewrite this in power form, in exponential form, just before we use the power rule. So we would rewrite this as 3, and we're going to move x up to the numerator. And when we do that, we need to make the exponent a negative. And so the -5 comes out front, and we get -15x. And we have to subtract 1 from this exponent, so -5 minus 1 is -6. I'm okay with that answer. If you don't want to have the negative exponent, you can move that back into the denominator, and we would have x to the 6th. So either one of these two answers is acceptable. Number 3. This one, similar to number 2 in that we want to rewrite this. This is going to be 5, and then this radical, this is an x to the first, so the 1 goes in the numerator of the exponent, and then the root goes in the denominator of the exponent. And now we use the power rule. So we have dy dx equals, the 1/4 comes out front, so it's going to be 5/4 x, and then we subtract 1 from that 1/4, and you get 3/4. -3/4, sorry. And we're okay with that answer. You could move that to the denominator, and we would have x to the 3/4. We are not going to rationalize the denominator here. The fourth one, y equals 2. We can think of this as a couple different ways. And I'm noticing up here, I wrote this wrong. This is not true. This is dy dx is equal to that. So number 4, it's a constant. A couple different ways to think about a constant. The graph of this line is a horizontal line, y equals 2. And the slope is 0, obviously. So the answer to this is going to be 0, but we also can use the power rule. This is just an x to the 0. The 0 comes out front, so 2 times 0 is 0. X to the -1, but 0 times x to the -1 is 0. So we'll just write this as y prime this time is 0. Number 5, we just need to know that the derivative of cosine x is negative sine x. The derivative of sine x for number 6 is cosine of x. For number 7, we have the y equals the natural log of x, so dy dx we learned is 1 over x. For 8 and 9, we have to use the power rule. The product rule. So for number 8, what we'll do is we'll think of sine of x, that's our first number, and then our first factor, and then e to the x will be our second factor. And so we can write dy dx equals first, so that's just sine of x, times the derivative of the second, which the derivative of e to the x is just e to the x, plus second, which is e to the x, times the derivative of the first, the derivative of sine is cosine. So that's our answer. We could factor out an e to the x. So we have, this is e to the x times sine of x plus cosine of x. And our last one in this section, again, this is a product. If we have a constant, that constant can go with one of those factors. So we'll think of 2x cubed times the natural log of x. And so we'll find our derivative using the product rule. We have first, which is 2x cubed, times the derivative of the second. Well, the derivative of natural log of x is 1 over x. And then we have plus the second, which is just natural log of x, times the derivative of the first. The 3 comes out, so we have 6x squared. This one does simplify some here, so the x's can cancel. So we have 2x squared plus 6x squared times the natural log of x, and we actually see that there's a 2x squared in both of those, so we'll factor out a 2x squared. And we get 1 plus 3 times the natural log of x. In fact, this could go one more simplification using the power rule for logarithms. So we could say natural log of x cubed. So either one of these last three are good. I don't want you to leave it in this first form because the x's weren't canceled. All right, for each problem, find the indicated derivative with respect to x. Well, these are looking for higher order derivatives. Another way to write this, if this were in function form, would be f prime prime of x. This is third derivative, so you put 3 primes. So those are just other ways of writing that. Number 10, the first derivative, dy dx, is just 10x. And then the second derivative, writing it in this form that they're using, is going to just equal 10 because we take the derivative of that again. Over here, we want the third derivative for number 11. So we have dy dx. Well, the derivative of cosine is negative sine. Second derivative, derivative of negative sine. Well, derivative of sine is just cosine, but derivative of negative sine is going to be negative cosine. And then the derivative, the third derivative, try to squeeze that in down here. The derivative of negative cosine. Well, the derivative of cosine is negative sine, so we have negative, so this negative sine of x comes from the cosine, and that equals sine of x. So there's the first page. Pretty straightforward. Make sure you know your derivative rules. The next page gets a little trickier. For 12, 13, and even 14, we use implicit differentiation. because none of these are in y equals form. They're in implicit form, not explicit form. So make sure we use the product rule when necessary. So right here we have to use the product rule. So this is first times the differential of the second. So that is 3y squared dy. So that's first times the root of the second plus second, which is just y cubed, times the differential of the first, which is 8x dx. So that's all from that first term. I'm going to actually put a plus 0 here because the differential of 2 is 0, so plus 0 equals, and the differential of x is 1 dx. And we want to solve for dy dx. So let's get all the dy's on one side and the dx's on the other side. To do that, we will just subtract 8xy cubed dx from both sides. 8xy cubed dx. And we get 4x squared minus 3. It's not minus at the times. So let's put that all together. So this is 12x squared y squared dy equals 1 minus 8xy cubed dx. We'll divide both sides by dx. Let's cancel here on the right. And then we'll also divide by 12x squared y squared. We're running out of room here, so our answer is dy dx equals 1 minus 8xy cubed over 12x squared y squared. Number 13 is going to be similar to that. We have a product rule in there, so let's just work our way through this. Zoom in a little bit, so hopefully I can fit it all in. All right, differential of 5 is just 0. So 0 equals, first one here is just 2x dx. Second one, we have a product rule. So we need to use that product rule. So we have plus first, which is x cubed, times the differential of the second, which is 2y dy, plus second, which is y squared, times the differential of the first, which is 3x squared dx. So now we want to get all the dx's on one side and dy on the other side. So let's go ahead and subtract this middle term. That's the only one with a dy in it. So we'll subtract that from both sides. So that's 2x cubed y dy. Subtract 2x cubed y dy. Over here we get negative 2x cubed y dy equals, all I have is these two terms left. So I'm going to go ahead and factor out that dx. So we have 2x plus 3x squared y squared dx. And we will divide everything by negative 2. Negative 2x cubed y. And we're going to divide, which I should have mentioned this before, also divide by dx. So we have dx dy on the left side. So our answer is dy over dx equals 2x plus 3x squared y squared over negative 2x cubed y. And that is our answer to number 13.